Hello, everybody. Welcome to CodeStats 13. There's the link. That's not the right link. No, don't click on that link. That'll take you to I don't know where. Somewhere within the Jari's class. Let me get the right link for you guys. All right. 1 second. Where'd you go? Links. There. There's the actual link to the attendance. Sorry about that. Let me pin my video. Come on in. Welcome to the class. See, I make sure I got all my stuff up here. Yeah. Sorry, one moment while I get things organized. Okay, maybe I do that. All right, so excuse me, sorry. I learned today, by the way, that if I talk quieter, my voice lasts longer. So I'm going to try speaking a little more quietly. If I'm speaking too quietly, please let me know and I will increase my volume. But I think this microphone does a pretty good job of catching everything I'm saying. So I will try to speak more quietly and save my voice to last for the whole entire quarter. Before we get going, I know last time I talked about maybe splitting the days between one day for Nimdari, one day for Whitener. And I think that's probably a good idea just because the classes are really, they're going in different directions. And while I imagine both classes are going to do all the things that they're supposed to do, they're going to do them in a very different order, it seems. So here's what I'm going to propose. I'm going to make a poll in Canvas, and you guys can go decide. Everyone can say which day they prefer to have Nimdari or Whitener. I'm going to do Nimdari Tuesday, Whitener Thursday, or vice versa. You can pick one of them, and whichever one gets more votes, that's how we'll do it. Now, that said, everyone can still attend both days. You're all welcome to be here. And the other thing, there was something else I was going to say about that. As far as the attendance and the weekly participation points, I'm not going to worry about it too much. If the points are too low at the end of the quarter, we'll fix it. I'm not worried about you guys not passing this code class. This should be the lowest priority thing you've got going on in your life, and yeah, just don't sweat it is what I'm going to say. As far as don't worry about the past assignments, Adeline. I think I'm saying your name correctly. I'll certainly you can do the quizzes if you want to, but it won't be required. Again, you guys are here to get help with your actual class. Making sure you succeed in this class is not really important. I just want people to participate, and that's why I'm having you do things. So that said, we're going to split the days. We're going to have one day for Nimdari's class, one day for Whitener's class, and we will have a poll, which I want everyone to do. I'll put it up today, and it won't expire, but we'll try and get it done before Monday so that we can actually have a decision as to who's meeting on what day. The other thing I was going to say is since that only gives each class 1 hour a week, I feel like that's not enough. So I'm going to make another poll asking what time on Tuesday or Thursday afternoon would be good for an office hour for each class. So I'll ask for Whitener and I'll ask for Nimdari. And I'm thinking something like 1 to 2 or 2 to 3 or 3 to 4, or maybe on the half hour, maybe 1:30 to 2:30 or something like that. So I'll make a poll, giving you some options as far as like who's your teacher and what time works best. And I think what I'm going to try and do is if, for example, we're having Whitener's class meet on Tuesday and Nimdari's class meet on Thursday, I'll try to do office hours for each class on kind of opposite days. So if we're meeting for Whitener on Tuesday at this time, then I would have an office hour for Whitener on Thursday in the afternoon and vice versa. So hopefully that'll give everyone the opportunity to kind of still get help with the things they need. But as I imagine you guys are noticing, things are, well, maybe you're not because you're not seeing what the other class is really doing, but things are kind of different in both classes. So that said, I did want to, I know a couple people asked me about box plots over the weekend, or in their, what's the word I'm looking for? In the weekly reflections, a couple people asked box plots. I do try to read those. I didn't read them as early as I would have liked to, so I'll try to read those sooner next time so I can address things on Tuesday versus today. But I wanted to go over a couple things. So I've been trying to follow along with both classes. That's not the thing I wanted. And I do really like the textbook for, I mean, both textbooks are good. I like the online textbook that Whitener has just because it does kind of have you do stuff along the way. So I wanted to kind of go through the box plot stuff from Whitener's class just because it's kind of easy to use. So I'm going to share my screen. I wonder if, so I'm going to share my screen. I'm going to look at something for just a sec. Just wondering if I can share my screen and have my video. I am clearly not smart enough to do that, so we're just going to do it just by sharing my screen. Oh well, such is life. Yeah, okay. So you can all hopefully see my screen now. Can you guys see me or no? I mean, you don't need to see me. I'm not like important or anything, but I'm just curious. Can you see my face? Oh, you can? Okay, good. Awesome. Great. That's good. I like that. That seems better to me. All right, so here is the screen. This is the data set about the age of Best Actress Oscar winners. And it's got from 1970 all the way up until 2013. It doesn't have the ages in any sort of order, but there it is. You can see it. It's not super useful. So then I'm going to click over here to talking about the box plot stuff. So here they've also got all the ages. And I think I did click on the data, and I'm not sure where I put it. Let me be smart about this. No, I don't see it anymore. Sorry. So there's all the data of the ages, and they do the summary for us. So they're telling us the minimum is 21. We can see right there, that's the youngest actress to ever win the Best Oscar. The maximum is 80, which is somewhere in the data set right there. And I'm going to close my window because it's kind of loud outside. Son of a gun. Too many pens. And they tell us the median and both the quartiles. So just as a reminder, the way we find those, so yeah, it would be really good to kind of be able to sort this data. Let's see what happens if we click on the data set. So we click on the data and it's, oh, that's the thing I had earlier. That's not super useful. So to be able to kind of actually organize this, we'd have to kind of grab it all. So let's try and be creative here. If I grab all these numbers, I feel like it's not going to go into Excel the way I want it to. We can always try. Let's try this. Nope. That seems terrible, right? We would really like those to be each in their own little boxes. So let's see. Let's do this instead. So we can type those in relatively quickly, but again, that seems like kind of a giant pain in the butt. Let's go ahead and do it. See, I should have done this ahead of time, but sometimes you don't realize you want to do something until you're doing it. Also, if you have other questions you want to ask about, you should be thinking about what those are. Oh, I know what else I want to say. So if you have questions, but you don't want to ask it in front of everybody, I totally get that. You are always welcome to send me a private chat as well. That's fine. If you have a question you want to ask, but you don't want everybody to know you're asking it. I think it's, I mean, whatever, that's fine. Also, oh man, this is, so see, this is, I feel like this is dumb to have to enter this all this way. There's probably a better way to do this. So the reason I'm entering this is so that I can order it. I know you guys really like watching me do stuff. It's super entertaining. Also, as a reminder, which I'm sure you all know, but I feel compelled to mention, you are able to watch the recordings at 1.5 or double speed, which when I'm watching other professors lecture, I certainly do to make sure that I am getting through the content faster. But I find it useful just to kind of get to the material. And you can always slow it down if you need to go or go back if something was unclear. Whoops. That was supposed to be 29 and then 62. All right, let's see. Did I get all the data points? Maybe. I don't know. Let's see. How many are there? Yep. So also something worth mentioning, just because I do this a lot. So we have Best Actress winners from 1970 to 2013, which means there are how many data points? Well, there's 44, because it's 2013 minus 1970, which is 43, but then you have to add one, right? Because 1970 to 1971, there's 1 and 71 and 72, sorry, 70 and 71, even though the difference is 1. So whenever you're trying to count the number of things in some years, you always have to find the difference and then add 1 because of the weird way that counting years works. So there should actually be 44, which we have, which is good. All right, so now here's what I'm going to do. I'm going to get that out of the way here. I'm going to sort my data. And so the way I'm going to do it, I feel like let's make this bigger. Sorry, let's do this. Let's change the font size so it's a little easier to see, hopefully. Maybe that's too big. Maybe I'm just old and can't see very well. That's not true. I have great vision. Okay, so here we go. So I'm going to sort this data, which I can do by going over to data. Whoops, come back. And then you can either sort or filter. Let's go ahead and sort. Column A, values smallest to largest, looks good, all right, do it, awesome, there we go. There's all my data sorted, and now I can easily find the median. So the median, since there's an even number of things here, the median is halfway between the two middle values. So the middle values are the values 22, are in the spots 22 and 23, and the average of those two numbers is exactly 34.5. If we look back over, so I'm going to move things around here just a little bit. Sorry, stuff is in my way here. Sure. Okay. So if we look back over to the actual results, oh yeah, the median was 34.5. Great. So then to find the quartiles, the first quartile is, so since we had an even number of values, the bottom half of the values are the first 22 values. And then the median of that bottom half is halfway between the 22 values. So again, since there's an even number, we have to do the average of the two middle values. Half of 22 is 11, so we look at 11 and 12, and the average of those is 30.5. Similarly, to find the third quartile, we go to the top half of the value, so we go from 23 to 44, so all those, and we look at halfway there. So we're going to do middle of those 22 values, so we have to go to the 11th and 12th value, and I'm not good at counting, so 23, the 11th value here is going to be, I think the 33rd one. That seems right. We could count if we really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it's the 11th one and the 12th one. So the average of 42 and 42 is 42, which is what we definitely got for Q3. The minimum is 21, the maximum is 44. Sorry, the maximum is 80 in spot 44. Okay, so then we can go over and look at where'd you go? The box plot for that data. So we're constructing the box plot. I don't think I really need to talk about this too much. You can play this little video if you want. They talk about how, holy smokes.
We'll construct a box.
We don't need to hear all that. So the way they construct it is you put the median right there, the third quartile is up there, the first quartile is down there. Let me just go back to this, sorry. Let me make this bigger for a second. Full screen seems like a choice that I don't want to make. So median in the middle, Q3 at the top hinge, I think they call that, Q1 at the bottom hinge. And then you've got these whiskers here. And the whiskers can be a little bit confusing, I think. So the way the whiskers work is you draw them as long as, but not longer than, 1.5 times the interquartile range. So that's, again, 1.5 times the interquartile range, which the interquartile range is literally the range of the inner quartiles. So where the IQR is just the difference between the third quartile and the first quartile. Oops, that's a Q3, not a Q pound. Sorry. And so if all of your data falls within those values, so this being, here the first quartile minus 1.5 times the interquartile range and up to 1.5 times it above the third quartile, then if all your data falls within that, then you just draw the whiskers up to the biggest and the smallest values. But if you have outliers, which are given by these little dots right here, and you use asterisks to draw them when we're talking about, what's the word I'm looking for? When we're drawing it ourselves, then the whiskers extend to the largest value that is within the 1.5 times the interquartile range above the third quartile. So we don't actually draw it all the way out to the value, but we draw it to the next value that we have. So I'm going to stop sharing my screen for just 1 minute here. So just for example, if I was drawing a box plot and I had some, say, outliers. So in fact, so I can actually do it for this one here. If we look back for just 1 second at our data. So the data they give us is that, so Q3 is 42. And I'm just drawing this, I'm not drawing this really to scale. So Q3 is 42, Q1 was 30.5. The median, or Q2, is, I believe it was 40.5. I don't actually remember, and it's of course not on this page. At least not easy for me to see on this page. Let me go back 1 sec. It was 34.5, sorry. And so then, if I look at this here, the interquartile range, which is Q3 minus Q1, is just 42 minus 30.5, which is 11.5. 1.5 times the interquartile range is 1.5 times 11.5. Decimals times decimals, everyone's favorite. I need to turn on my calculator before I try to enter stuff. Good call. It's 17.25. So that means if I'm going to draw the whiskers, the furthest they should extend to is 42 plus 17.25, which would be 59.5, 0.25. So then here's the thing. That's actually not an age we have recorded, right? Everyone's ages we recorded is just a whole year. So what we're going to do is we're going to find the largest value that is within that. And the largest value within that, wow, was actually 49. So so if this was actually that value here, we would go back and say, well, we're only going to go up to 49. Because that's the biggest value that's within the interquartile range plus Q3. And then, sorry, where'd the chat go? Yeah, okay, there we are. And then these other data points, and I'm just looking back at my Excel file. So I'm going to share that screen again with you guys. Sorry, I know that we're getting kind of complicated here. Oh, wow. Life is complicated sometimes. So I look back at this Excel file here, I see that, okay, 49 is the biggest value that's within this 42 plus the interquartile range. And then the next values, 61, 61, 62, 74, and 80 are all outliers. So those all go out here. 61, 61, 62, 74, and 80. And these should be to scale, but right, I'm not doing a great job of that. So that's what those are. That's 61, 61, 62, 74, and 80. 80? Yeah, 80. And then we do the same thing on the other side. So we go 30.5 minus 17.25, which is definitely what? I don't know. It's something. It's 13.25. But the youngest actress, I think, was 21, right? So although we could extend this whisker as far down as 15 or 14 or not 13 because 13 is too far. But we don't have to because we just extend the whisker to the lowest value that's within the range, which is 21. So that's how you draw a box plot with all the information. And hopefully that kind of helps clarify things a little bit. Now, the other thing about box plots is kind of how we use them to interpret data. So still sharing my screen, right? Yeah. Okay. So I've been going through most of her stuff and just looking at this. So if we look at this question here, sorry, hopefully I'm not being too quick with my mouse. So yeah, so yes, to answer your question, Adeline, the whiskers, right? So this 1.5 times the IQR, this is the furthest length. This is the furthest a whisker can extend. And anything beyond that is considered an outlier. So yes, definitely. So looking at some of the questions on the book here, which again, I think are good to do. This one's asking, choose the correct label for the point on the box plot here. Why did I only extend to 21? Because 21 was the lowest value. And so definitely this was always, I think, a confusing point to me as a student. And definitely, I was actually just talking to my coworker the other day, and she knows this stuff very well as well. And she was like, I don't remember how this works because it's not always clear. So we only extend the whiskers as far as the data actually allows us to. So since the data has a minimum value of 21, we stop the whisker there. On the other side, since the data extends beyond the max, so right, this is the maximum value of the whisker. So you guys probably can't see that very well. Let me stop sharing my screen for one moment. Right, so on the other side here, right, the whisker could extend. Let me fix that just a little bit. So there's my 1.5 times the IQR, which would get me all the way to 59.25. So that's as far as we could have extended the upper whisker, but we only extend it to the value, to the highest value we have that's within there. And so we can't go quite to 61 because that's too big. And then the next value under 61 was 49. If the problem doesn't give you the minimum and the maximum, then you probably aren't able to make a box plot very easily. Usually you kind of have to know the data to be able to make a box plot. Okay, so back to this. I'm going to share my screen once again if I can remember how. Yep. Sure. Maybe. So looking at this, we can kind of answer these questions pretty easily. So again, if you read, so again, this is the bottom 0, this is the upper. So they've actually drawn the box plot, and this is the box plot that I tried to draw. They've drawn it vertically instead of horizontally, that's fine. And so you can see, I feel like that looks, I feel like their box plot looks, maybe this is different data. Sorry, I'm going to click on this for just one sec. Apologies. Oh, these are actors, not actresses. So I was like, this doesn't look the same as our data here. Okay, so they did it for actors here. Here's the box plot, and they're just asking to identify things. So this first part, that's definitely Q3. That's the upper interquartile. And then you can do the next thing, right? And this isn't graded. This is just to check your understanding. So then this question mark here, that is the, well, it's not the minimum or the maximum because the maximum is this outlier out here. So that would be probably none of the above, actually. And then we can go to the next thing. So then this value here, so in fact, they even told us, right? That whisker there ends at the largest observation that is not an outlier. This value up here would be the maximum. That value down there, since there aren't any outliers below it, this value to the whisker is the minimum. They're asking now for this part here, which is the Q1. That's the bottom quartile or the lower quartile. And then what else are they asking us for? This question mark here, that's the middle line, that's the median. Yeah, if you don't have any outliers, the maximum and the minimum would occur at the whiskers. So the maximum would be here where I'm pointing out with my pointer if there wasn't an outlier up there. And the minimum is here because there are no outliers down there. Same kind of thing is true for our best actress or best female actor, whatever they call awards. Right, the minimum is 21 and it's at the whisker. The maximum is 80, which is an outlier, which is not at the whisker. But if we didn't have any outliers up here, then the maximum, like if none of these data points existed here, then the maximum would be 49 and would be at the whisker. Middle line is, of course, the median, which is capital M. This length here between the bottom value and the top value is the range. And finally, the length here between quartile 1 and quartile 3 is the interquartile range. I don't know if it's inter or inner, either way. And that's it. And then they give you some data you can practice with. I don't think we need to go through that. You can actually also do this. So this shows more stuff. There were some interesting questions actually around this, talking about kind of how to interpret where there's more of the data. So looking at this question here, this is displaying TV ratings for TV shows during Sweeps Week. So 50% of the shows have a rating greater than which value? So the median line, right, that line right there, looks like it's about 14. So that separates half below and half above. So I would guess 50% of the shows have a rating greater than 14. That looks good. What is the percentage of shows that have a rating of less than 20? Okay, so 20 is right there. That's where the third quartile seems to be. So 75% of the shows would have a rating less than that. Awesome. Within which interval of rating would you expect to find the largest number of shows? So this is where we have to be a little bit careful. So the interval has to have kind of the most of the horizontal lines in it. So if I look here, 5 to 10, whoops, that's not what I wanted to do. So looking back at the data, starting at 5 and going up to 10, I didn't even get a quarter of the data, right? I got not even the whole bottom quarter. If I go from 10 to 15, I'm getting some of the bottom quarter, all of the second to the bottom quarter, and some of the next quarter. So I'm definitely getting more than a quarter. If I go from 15 to 20, 15 to 20 is going to be less than a quarter because I don't have all of the median to the third quartile. And finally, 20 to 25 is going to give me exactly 1 quarter, or no, not even 1 quarter, because again, I'm not getting all of the fourth quartile there. So 10 to 15 is the range or interval that has the most data of all those intervals because it's got more than a whole quarter of the data. And they explain, so, and then when you select your answers here, it explains what's happening. And let's look over at the next part. So this is the last part of the, is it the last part? Yeah. Excuse me. So lastly, we then start looking at comparing box plots of data for different things. So for example, they're looking at the average high temperatures of San Francisco versus Pittsburgh. And when I look at this data, before I see anything else, I notice that there's a lot more variability in the temperatures for Pittsburgh because their box plot is a lot longer or wider, depending on how you draw it, than it is for San Francisco, right? So we can see that the the range of temperatures for Pittsburgh, of high temperatures, I should say, is as low as 30 something and as high as 80 something. Whereas the range of high temperatures for San Francisco is as low as 50 something and as high as, I don't know, maybe almost 70. Seems kind of sad. And then they kind of go through and they show us all the data with where the quartiles and the mins and the max and the median are. And I guess that's it. I felt like there was more to that. Maybe not. Maybe I'm just sadly mistaken here. Yeah, then they gave us some data we can work with. I never fill these things out. I guess that's it as far as box plots. Okay. So I think that's fairly, yeah, okay. I can stop sharing my screen with all that. So let me ask you guys, are there questions you would like to ask about box plots? Or are there other questions you would like to ask? I know Nandari posted a quiz today. It looked really long to be what I would call a quiz, but it definitely looked like something that would be a fair amount of work. Actually, I can take a look at it for a second here. Yeah, there's a lot of questions on his quiz. Sorry. Okay. I've had questions when you compare two box plots. Okay. I thought I had some good examples of it. I thought, let's take a look here. Oh, there was like, I think there was some good, I think there was questions on the quiz. So if we go through here 1 second. I think I already did the quiz. I mean, I might not be able to do it again. Let's see real quick. No, yeah. Can I do it again? I can maybe do it again. Maybe I can't. No, it doesn't look like I can. Oh yeah, I can. Oh no, I can't. So well here, so let me share my screen again, just to kind of show you guys at least one of these questions. So yeah, here's one of the questions on the quiz that I did. The box plot, one actually did two because I got a question wrong the first time. So the box plots below show the number of marshmallows in a bag as estimated by students in 2 elementary school classes. So Mrs. Apple's class estimated the number of marshmallows in the bag to be as low as 25, as high as 250. And then had a median value of 75, upper quartile or a third quartile of 125, lower quartile of 50, or first quartile of 50. Mrs. Banana's class, they had a minimum estimation of 50 marshmallows in the bag, a maximum of 200, first quartile 75, a median of 100, and a third quartile of 125. Now, the question they ask is not, I think, very interesting. They ask which class has more students, and we don't know, right? These quartiles, when you're just giving the graphical information, they don't actually tell us anything about how many respondents there were, right? If we look at this best actress data up here from our box plot, if you just have the box plot without the raw data, we can't tell how many we were actually looking at. We know what the minimum and the maximum were, we know what the quartiles were, but we don't know how many are in each of the quartiles. And then, okay, there's another question here. Question 6 asks more questions. Which class has greater variability in the student's estimate? Well, that's also a not too hard question to answer. It's really just the box plot that covers more range. So this box plot has a range of 25 to 250, which is 225. This other box plot has a range of 50 to 200, which is a lesser range. So there's less variability there. Now you might compare the ranges. You might also compare I think actually the interquartile range is what we usually use to talk about variability when we're thinking about box plots. So in this question, I probably actually said Mrs. Apple's class because the interquartile range of Mrs. Apple's class was larger than the interquartile range of Mrs. Banana's class. Let's see what they say here. No, they actually said the first thing. Sorry, I would say you could kind of go either way on that, but yeah. And we can look at question 7, which is asking, let's see if I can scroll and not show you the answer before I get to the question. Which class has the greater percentage of estimates over 100? Good question. So there's 100. Yeah, this is the kind of question I think is actually the one that maybe takes the most kind of thinking. So if I look at this, if I look at the 100 line here, which I wish I could draw on my computer, maybe I can. I'm not smart enough to do that right now. So look at the 100 line here. I see that Mrs. Apple's class, well, we don't have 2 full quartiles, right? We have less than 2 full quartiles and more than 1 quartile, right? Because from here to here is the 4th quartile. from here to here is the third quartile, and here's the second, here's the first. So we have all of the fourth and some of the third. So we have between 25 and 50% of the data above 100. For Mrs. Banana's class, the median is right at 100, which means exactly 50% of the data is above 100. So Mrs. Banana's class has more estimates above 100 because we're grabbing more of the quartiles than Mrs. Apple's class is. Question 8, the box plots below show the number of marks. Oh, sorry, which class has a greater percentage of estimates between 50 and 100? So between 50 and 100, so 50 to 100, Mrs. Apple's class has a quartile and then some, so more than a quarter, but less than a half. Mrs. Banana's class from 50 to 100, again, has 2 full quartiles, right? We get all the way from the bottom to the top, so that's half. So again, Mrs. Banana's class has more data. And the way you can think about this is her data is more compressed into a smaller range. So it makes sense that most of the time, if you're asking about a certain range, the one that's more compressed will have more of their data within 2 specific values. That's lots of good questions. So I think, well, the quiz, I guess, is required. So, like, but even the optional stuff for Whitener's book is, I think, good to do. I'm looking at these last ones here. Last one, sure, might as well. We're here, might as well talk about it. So, based on the results of a nationwide study, the number of contacts programmed into cell phones are summarized in the following plot. So, looking at this data, the lowest observation is outlier is not true, right? We don't have any asterisks down here, nor do we have any up here, so there are no outliers. The data is skewed left or right, could be hard to tell. You might be able to make an argument that the data is skewed to the right because you have it being longer on the right-hand side. But to me, the right answer to this question is that there are no outliers because there are no asterisks anywhere. They don't say anything about skewness here, which is too bad. We'll go to the next question. Which interval contains the greatest amount of data? So here, if you go from 0 to 50, you've got a quarter of the data because we're up to the first quartile. If you go from 50 to 100, you've got more than a quarter, but less than a half. If you go 100 to 150, so 100 to 150 is really unclear because you've got some of this quartile and you've got some of this quartile, meaning you could have very little, actually. You could have as little as like barely anything, because you'd have like just a smidgen of one quartile and just a smidgen of the other quartile, or you could have really up to close to 50%. So from here to here, you could have anywhere from 0 to 50% of the data, essentially, maybe not quite 50%. So how do you have more than a quarter, less than? So for 50, so here's where, so from 50 to 100. So the median cuts off the lower half from the upper half. So what I would say about this data is half of the data is below 75 and half of the data is above 75. Doesn't mean we have half the data exactly. I see that from 50 to 75, I have a quarter of the data. From 75 to 100, I have part of a quarter. So all I know is that from 50 to 100, I have more than a quarter, but less than a half because I don't have 2 full quartiles. So each quartile from 25 to 50, 50 to 75, 75 to 125, and 125 to 200. Each of those quartiles has exactly 1/4 of the data. So 50 to 100 has somewhere between a quarter and 50%. And then from, sorry, what was I saying? From 100 to 150 is really kind of hard to tell. It could be anywhere as low as almost 0 to anywhere as high as almost 50%. Because maybe there's really not very much over here, and maybe there's really not very much over here. It's hard to tell. And then 150 to 200, we know there's less than a quarter of the data because we have less than a full quartile. So in this case, it's impossible to tell which is more. I don't know if 100 to, I don't know if 50 to 100 is more because it's definitely more than a quarter and less than 50%. And I don't know if 100 to 150 is more because again, it could be anywhere from 0 to half. Oh, sorry, yeah. Sometimes the max and the min value, sometimes people call them fences, whiskers. The terminology I get kind of mixed up on, I'm sorry. I think this part is called the whisker, and I think this part is called the fence. I'm not really positive about that though, so don't quote me on that. All right, and I think that's, yeah. Let's call it there as far as box plots. So, and I've talked about box plots a lot because, and I think they're kind of cool. In fact, I remember I figured there is definitely a way. Not that this is maybe an old person thing. On my TI-83 graphing calculator, there is definitely a way to make a box plot if you enter all the data, which is kind of cool. If you're interested, I could show you that. Maybe, I don't know. I didn't check on that. But you've also, right, you've got a computer at your disposal. There's probably an easier way to just do it on a computer. So, are there any questions from the Nimdari crowd about maybe non-box plots, non-box plot things, or other questions just in general? Let's see. I did have one. I was like, where? Okay. The law of total probability. Sure. Although, I think I know what that means, but I have to make sure I'm certain. The problem is lots of times things have names. I'm like, I think I know what that name is. Let me search on Google real quick. I think that is. Oh yeah, okay, sure, of course. Yeah. So in fact, I think this goes well with a question. I'm going to do a question similar to one he has on his current quiz, but not quite the same. Where'd you go, quiz? This is going to be similar to his question number. Oh, where'd you go? I was looking at this earlier. Question number 11. So for a particular disease, I'm going to use some different numbers. The probability of having the disease in a particular population, I'm going to say is 0.01%. So the probability of having a disease is 0.01%. We shouldn't use percents. We should say that it's 0.0001. The probability of having a disease is 0.01. Oh, sorry, 0.0001. And someone from the population has the disease. The probability that he or she tests positive, I'm going to say, is going to be it's going to be 0.97 or 97%. So given that, so this is a conditional probability, right? Given that someone has a disease, the probability that they have a positive test for the disease is 97%. And then we also know if the person does not have the disease, the probability they test positive is going to be, I think I decided to make the number 0.02. So the probability that they test positive, given that they do not have the disease, which I'm writing as D complement, right? That's having not the disease. That's going to be 0.02. By the way, this is often called a false positive, right? Where you don't have the disease, but you test positive. Okay, so the question we want to answer is, what's the probability that a randomly selected person from the population has a positive test result? So what's the probability of testing positive? And there's a few ways to answer this. And I'm actually going to do it kind of what I think is the most logical way at first. So you've got a person. or whatever, a sample point. And there's kind of two different things that can happen. They can either have the disease or not, right? Those are the two options. So they have the disease or they don't have the disease. And the probability of having the disease, well, we know the probability of having the disease in the population is 0.0001. The probability of not having the disease, well, when you're talking about two things where one's the complement of the other, it's just whatever's left over. So there's a 0.0001 probability of having the disease. There's a 0.9999 chance of not having the disease. One more 9, sorry. Okay, but then from each of those, there are two things that can happen. If you have the disease, you can either test positive. Well, given that you have the disease, so again, when you're making this tree chart, which mine looks kind of funky right now, when you're making this tree, the given thing should always be the first branch of the tree. So given that you have the disease, the probability of a positive test is 0.97. And so given that you have the disease, the probability that you have a negative test should be whatever's left over, right? Because 97% of the people who have the disease test positive, the other 3% test negative. Same sort of thing down here. If the probability of testing positive given you don't have the disease is 0.02, then the probability of testing negative given that you don't have the disease is 0.98. And here's kind of something worth knowing. Whenever you draw this tree diagram, each kind of set of branches, and I've drawn mine extra stupidly, I feel like. Sorry. Usually it's not quite this dumb looking when I do it this way, but whatever. So each branch should add up to 100% or 1. This plus this adds up to 1. These add up to 1, these add up to 1. So each of those should always add up to 100% so that right, you've got all the possibilities kind of laid out. So I want to know the probability of having a positive test. So I'm going to find all the paths to a positive test. So I can either have the disease and then test positive. So that's going to be, and I'm going to write this out more clearly in a minute, 0.0001 times 0.97 plus the probability of having not the disease and testing positive, meaning that would be 0.9999 times 0.02. Now, the way this looks is the following. It's the probability of, well, there's a couple ways, so I'm going to write it in one way and then another way. Let me give myself enough room here. So this 0.0001 is the probability of having the disease. This 0.97 is the probability of testing positive given that you have the disease. Same deal here. This is the probability of not having the disease. This is the probability of testing positive given that you don't have the disease. And then an alternate way you could write this is, well, the probability of having the disease times the probability of testing positive given that you have the disease is just the probability that you test positive and have the disease. And over here, this is the probability that you test positive and you don't have the disease. So the way this picture, I don't want to erase anything. I guess I'm going to erase this. Sorry. So the way this picture looks is if, right, and I think you drew a picture kind of like this in class, right? If here's the people that have the disease, and here's the people that don't have the disease, and here's the people that have tested positive, right? Then the people that have tested positive, well, right here, that's the part of people that test positive and don't have the disease. And right here in this little smidgen, that's the percentage of, that's the probability of testing positive and having the disease. So that's why you have to do this plus this to get all the people that have a positive test. Now the numbers here are not that important, but we can find them, right? If you calculate this, it's going to be 0.0001 times 0.97. Oh, I forgot the attendance form. Sorry. You guys have to remind me about the attendance if I forget. Oh, that's not that. Sorry, one sec. Where'd you go, attendance form? Why would you abandon me in my time of need, attendance form? Sorry, 1 second, I apologize. So yes, if I forget to do the attendance, please remind me. Because although some of you might have it bookmarked, some of you might not. So please, everybody go to the link, fill out the attendance. It's real easy. But to finish this off, sorry, it was 0.0001 times 0.97 plus 0.9999 times 0.02, which ends up being 0.020095. So this makes kind of sense in a way that the probability of getting a positive test is really, really close to the probability of getting a false positive test because, what? That's weird. I haven't had that problem in a while. Well, shoot, I will go fix that right after class and send you guys an email via Canvas so you all fill it out. Oh, well, that's weird. I don't know why there would be some of you being able to use it, some of you not. I will try to fix it. So everybody fill it out that can. If you can't, I'll just record your attendance because I can find it from the Zoom record data anyway. So please do fill it out there because it's easier for me if you just fill it out. But if you can't, I will try and see what's going on there. So back to this, sorry. It seems sensible that this percentage is really, really close to that percentage because most of the population doesn't have the disease in the first place. One thing I'll say about this is eventually we're going to go towards something called Bayes' formula, which talks about using this to calculate what's the probability that you have the disease given that you have had a positive test. What we're going to see is it's really not at all the same as the probability of having a positive test given that you have the disease. Right? These are very different things, even though they kind of sound the same. All right, so I'm going to end it there. I'm going to try and remember. I might record this down so we can use these same numbers again in the future. My wife is talking about Tiger King. So fill out the attendance form if you can. There was something else I wanted to say. I'll put a poll up to see which class we do which day, and I'll also put a poll up or something to ask you guys about when would be a good time on Tuesday and Thursday to have office hours. Yeah, that happens to me too. Yeah, so if you happen to be logged into your non-UC Davis account, it can be that it's not accessible. That definitely was a problem for me when I was first doing this. All right, sounds good. Take care. Good luck on the quiz for those of you in Nindari's class. Can we go over sampling? We definitely can next time, but we're out of time. So I will definitely look at sampling stuff. Maybe I'll try. So we are out of time. I'm actually over time, and I don't want to keep you guys over time. So you're welcome to go if you need to go. But what I will say is if there's something you'd like me to talk about that we didn't get to today, but you want to see it before next Tuesday, which is when we meet again, let me know. Adeline, I will try to make a video about sampling, but if you want to maybe shoot me an email or start a discussion thread on Canvas, it's probably even better. If you want to start a discussion saying like, can we talk about sampling and here's what I'd like to know, I can definitely try to make a short video talking about it. All right, that's all I have for today for you guys. I will let you know about the polls and take care. I'll talk to you later. Don't forget, send me an email or preferably start a discussion on Canvas and we can discuss things there as the name would imply. All right, I'll talk to you guys later. I'm going to end the video.